All right. All right. Let's look at friction in an inclined plane. Let's assume we have a plane inclined at angle theta horizontal, and a body of mass m is placed at P along the plane AC. In doing this, there's going to be a net force, a net parallel force acting this way, a net force. The net force can be zero or more than zero. If a force is tending to push the body downwards with a force small letter f, then a frictional force in this direction is going to oppose this motion. Frictional force, let's call the frictional force Fr. So the magnitude of these two forces respect to each other will determine the size of the net force. And of course, the net force must act parallel to the plane. Secondly, there's going to be a normal force. A normal force that must act this way, that must act at angle 90 to this plane, angle 90. Now, how do we find how big or how small the components of these forces are? Let's call these components parallel to the plane as delta F parallel with FP, and the component parallel to, perpendicular or normal to the plane as delta Fn for normal. And of course, the body is going to be exerting an amount of force called the weight. The weight of the body is going to act exactly purely vertically downwards in this manner. So this is our W, which is equal to mg. How do we now determine this particular angle? To do that, let's consider this triangle. Let's consider this particular triangle. This triangle. We know that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. The exterior angle of this triangle is given by the sum of the two opposite interior angles, which are this and this. And of course, this place is at angle 90. So mathematically, let's call this angle x. That means the exterior angle x plus this place, which is 90, according to mathematical law, must be equal to this interior angles, which is theta, plus this other interior angle, which is 90. Subtracting 90 from both sides, we know that we have that x is equal to theta. That means this particular angle is theta. Next, to find out the F parallel to the plane, let's draw a parallel line to this line, this way. Of course, since this place is 90, here must also be what? 90 by the virtue of corresponding angles. So considering, okay, this is point D, let's call this P and Q. Now, summation Fp. So to find the expression for summation Fp and summation Fn, which are the parallel components of the force and the normal component or perpendicular components, let's consider triangle DPQ. We know that sine theta, of course, sine is given as opposite over hypotenuse. So in this case, sine theta is given by sine theta is opposite here is delta F parallel over hypotenuse, which is W. So that W becomes equals to, so that net parallel force is given by W sine theta. Now, of course, the weight of the body is given by its mass, translation to gravity, which is G. So now to get the net normal force, we can take the cosine of the angle theta. So cosine theta is given by cos is adjacent over hypotenuse. So cos theta is equals to adjacent, which is adjacent, which is summation F normal over hypotenuse, which is W. So that the net normal force is given by W cos theta or mg cos theta. So as a recap, in a parallel plane, there are two major components: F parallel to the plane, which is given by any force, any external force on the body, plus or together with frictional force. And of course, the magnitude of the two forces will determine whether the body is accelerating upwards or going down or at rest. When this F is equal to this frictional force, the body is at rest. And when frictional force, when the particular force applied downwards is more than frictional force upwards, the body slides downwards. The second component is the component that is perpendicular to the plane, which is the normal reaction force, because actions and reactions are equal and opposite. Because the body is exerting weight downwards, there must be what? A reaction force perpendicular to the plane. But because the plane is not purely horizontal, the normal reaction in this case cannot be equal to the weight as we see it when a body is purely horizontal. So the two components now are the F parallel and the F normal, which we have derived the formulas as F parallel to be this and F normal to be this. See you in the next video. Thank you.